Okay, I think we're like at 4 o'clock, so I'm starting. So first of all, thank you so much for coming to my talk. My talk is called Reactive for the Impatient. Um, Thank you. Yeah, so my talk is Reactive for the Impatient, and I specifically says it's Java edition, but don't kind of get scared. I mean, yeah, I understand a lot of folks actually don't use Java these days. But anyway, it's mostly actually on concepts and some design thinking before I go into some samples of four of the popular Java tools. But let me introduce myself first. My name is Mary Grygleski. I'm with IBM. I'm a developer advocate, and then for the like a relatively new team just started back this summer last year. We're doing like Java development effort in advocating. So as advocates, we go out and do outreach work, and then talk to developers like yourselves, and do this, and then trying to build up a relationship. And we're not, even though, yeah, I work for IBM, I may be talking about certain products of IBM, but the goal too is to really bring technology to everybody, and especially with IBM, it's no longer the dinosaur company as some folks may think of, because as you know, they started off actually creating typewriters, like in olden times and very old machines and all that. But now these days we're going into for software, we actually encouraging open source, and IBM is a really big proponent, supporter of open source technology as well. So yeah, so I'm a developer advocate. I've been working in the software engineering development field since 1988 when I graduated. And I'm really seeing a lot of very interesting changes, and some concepts seems to be like more like, even like for reactive, for example, it comes out like, oh, the hard things and new things, but as you find, if you really dig into things, the concepts are not really new. It's just like maybe new labels, new way of putting in onto that, for example. Actually, yeah. So now too, I'll explain to why all of a sudden reactive becomes such a hot buzzword, and then also trying to clarify some of the concepts around this reactive word. So yeah, that's what I'm going to be talking about. So so as such, this talk too is really a very gentle introduction to reactive programming, reactive systems, with a survey of four popular Java-related tools, libraries, and frameworks: RxJava, Spring Reactor, Akka, and Eclipse Vert.x. How many of you? Let me kind of just get an understanding. How many of you, first of all, are Java developers in here? Yeah. Okay. Cool. Yeah. So yeah. Cool. And then, how many of you have worked with like reactive systems and programming one way? Okay. Very cool. Let's see. So, are you like reactive systems in Java, or is it JavaScript? And JavaScript, yeah, yeah, maybe like a mixture. So yeah, so I just like to get some understanding. So yeah, okay. So now let me start. And you are also welcome to ask questions too if anything is there. And as such too, I also want to kind of point out too, again, reactive is a very overloaded word. It's being used by a lot of like marketing and literature too, and products and all that. So it may be confusing too. So I'm hoping this talk will give you like a better sense and clarity on these what reactive is. So first of all, we talk about like why reactive. Okay, so it, like as I mentioned, reactive is not a very new thing that just came out in the past 5 years or so. But true, like within the past 4 or 5 years, maybe there's been a lot more, marketing things and products that come out. And the reason is that these days too, with the hardware, with the CPUs, we have multi CPU, multi cores, and also like hyper-threading, for example. So it allows the software to be written in such a way that can make better use of the hardware. Yeah, so it used to be too, like it's everything, single thread, and your machine, your processor, everything is single thread, and it works very well. It naturally, with your program, it kind of works well with the hardware. But now with these multi-threading or multi-CPUs and multi-core CPUs and all these, actually it requires the software to become more sophisticated in order to take advantage of the hardware improvements. So then, like as a result, too, you now are seeing like software companies, for example, Lightbend. How many of you have heard of Lightbend, Akka, like reactive? Okay, No problem. That actually is a Akka is a reactive library, and also is started by the company called Lightband in Sweden. And actually the founder of that is Martin Odersky. He's the inventor of Scala. Have you actually done any work with Scala? Maybe, yeah, maybe, right? Some, or maybe not. Okay, so Scala is the programming language that runs on Java virtual machine. So yeah, but anyway, so Lightband is started by Martin Odersky in Sweden there, and then it slows. It also like puts an emphasis on like functional programming, and also then it brings out the reactive and functional programming aspect of systems, and they really go deep a lot of the bringing out the true value of reactive systems. So yeah, so going back, so companies like Lightband, they come out and they develop these pretty sophisticated reactive systems, what it is. So on the Java side or JVM side. So, and then of course too, on the software system level too, there are like demands too right now change. You know, consumer or even like companies too, they want systems essentially to respond faster and all that. So then there are like new paradigms in, you know, doing software development or new way of doing things, new way of structuring your program. So there's this need for this new way of doing things is reactive. Again, not new, but it's just like it's able to kind of, you know, the software system is able to get caught up to kind of take advantage of the hardware. And then of course too, human beings, we are just naturally very impatient. How many of you like to wait, right? You want something, you want it right away. So there's always that kind of aspect, a human aspect, that the demands that come in which it just pushes us, this invisible force, and you know that we created ourselves, and pushes everything to react faster. So, okay, so now I get into like what is reactive. So first of all, I bring to your attention, there's this reactive manifesto. This one is actually led by Lightband, the company that IBM has a partnership with right now, and that's the system that IBM is essentially trying to like support more to, is the reactive system from Lightband. So this company, they started basically have these initiatives of drafting up a reactive manifesto. So this is the URL that you can visit to get more deeper details into it. But essentially, I just want to highlight the latest version of the manifesto. It lays out essentially the principles and what it is trying to achieve, right? And as such, so to the user, to the end user, and then to programmers like us, it becomes like they're aiming at more flexible systems. You are basically isolating your pieces of your code, like time and space and everything, resources, they isolating it, making it more detachable, so then it's easier when they all communicate together rather than tightly coupled, that kind of principle. So, and then also, not only that, on a programming level, it makes the programming, program structure a lot more elegant too. Maybe some of you are doing JavaScript, I believe, and then you can actually do, like, you chain your commands, which they are transformer, right, in functional programming, for example. So that's an aspect of programming that is actually a big improvement too. That Java version, you've heard of Java, the version 8 that comes out with functional programming and Lambda. That's when, yeah, Java is able to kind of get caught up, so to speak, into like functional programming support. So, okay, so Reactive Manifesto is essentially emphasizing on highly responsive systems, meaning that you don't want to have too much wait time. I mean, you still wait, but it's kind of, you want your request to go and then the response come back in a timely fashion. And not only with responsive too, it's really the way that how it handles failure. Before, like for example, your failure of a system, your program would have to handle it. But now too, what happened is that inside the framework itself, it has like it has like the mechanics of it too, the system itself, it will know how to handle. For example, error, like in Java, right, is an exception, or in a programming language, is an exception, then you have to handle it. But then in reactive, like terminology, exceptions and errors become like first-class citizen. It's just an event. So then it's up to the programmer, the programs itself to recognize, okay, event comes, I need to figure out, is it an error? Then I need to handle it accordingly. So in that sense, it's like a first-class citizen in a programming kind of construct. So, and also again, like handling of failures. For example, in Akka too, it has this capability called supervisor capability. So what happened is that in a complicated system, right, you have different components. The components itself would have the capability of telling the parent. Now, in an Akka system, for example, Akka has in what they call like an actor programming model. So essentially, the actor model, the actor is the one that's like responsible for your component. And then that's why too it's suited too for doing like say microservices, that type of thing, because your parent of your component will handle all the stuff that's needed, the communication, for example, searching for components, like especially distributed systems, right? How do you find each other, that kind of stuff. So the actor itself, it has built-in mechanism in which it can handle like the handling failure and notification much better, because the component itself has the self notification system that tells the actor, hey, I'm like behind now, can you do something, for example, like in a conceptual level, right? So like that. So hopefully it makes sense, but I'll go a bit into some detail. Hopefully not confusing you at this point. Okay, so now too, again, when we come to like reactive systems, there are like, I'm sure maybe some of you have seen this diagram. It's like the 4 basic tenets of reactive program. So again, I already spoke a little bit about being responsive. It's being able to respond to your requests in a timely fashion. And then for elasticity, which is, if you think of it, it's like an elastic band, right? So it's like if your system is under heavy load, and it should be able to scale itself and be able to add more resources to handle your load. In that sense, that's what elasticity means. But as such too, there's a bit of subtlety. It's not quite exactly scalability in the sense that elasticity in a reactive manifesto is actually about throughput. So your system can actually handle your load coming in, your throughput should still be able to like expand it. Think of a pipe, right? That you build a bigger pipe so like more data can pass when it needs to get through. And then when the load is low, then your pipe will kind of shrink back and then adjust accordingly. So you should have that kind of elasticity capability. And then resilient. Earlier I mentioned too, it's about the failure. How do you respond to failure? And being able to recover. Without like a failure situation, you don't just like die and let somebody deal with it. It's more like failure, and then you respond to it right away. So handling failures in a responsive manner. And then one of the things too, like how can it, we can encourage systems to do all 3 things. It's really the message-driven nature of these reactive systems. So basically too, message-driven is, I'll explain too, it's more for like reactive systems versus reactive programming. And I will tell you the difference in a second. But just remember too, like message-driven is the way how you do things to enable reactive nature. Because as such too, I also haven't brought up the word is about reactive programming is really supporting your calls to be operating in a non-blocking manner. So now these days, right, by default, I think our human brains also always think of doing things when we send a request, wait for the response to come back. But in a reactive way, what we want to do things is that we send a request and let the request be handled by somebody. In the meantime, we go and do something else and not be bogged down by waiting. So that's what it's like non-blocking. So that's a very important concept in reactive programming, is the asynchronous nature of programming. So I mean, as such, you can tell too, if we do asynchronous programming, it's always bring back a bit of a challenge too, as I'm sure some of you are aware of. Then what do you do, right? When response come back, how do you know the response is, how do I process them? So that's the kind of challenge too, in which these reactive systems have built-in mechanism to handle that accordingly. So yeah, anyway, so that's what the message-driven essentially. Okay, so some important distinctions. It's like a bag of fruit, right? So you might have heard of, everybody has heard of RxJS, JavaScript, React Native. Okay, so those are actually more for the JavaScript side of things, right? And Java and React is actually, and React Native too, they are started by Facebook engineering. So, and they are more like JavaScript way of doing things. Now, I'm not going to go into that detail, but there are also certain aspect of like, all of these functional programming side of things that goes into those and reactive systems. But I just want to point out in a Java way, we like at least also too when I first learned about it, I tried to separate them out. So reactive programming is really, again, it's the asynchronous nature of programming. And also a very important thing about reactive programming, how is it different from functional reactive programming, right? So essentially too, reactive programming is really a subset of asynchronous programming and a paradigm where the availability of new information drives the logic forward. So in other words, like it's handling events that comes in. So if there's a change in the data, then that change in data will actually propel the logic to go forward, is what it is. Okay, I know it's kind of confusing, but I'll show you some examples shortly. Whereas in functional reactive programming, which I won't go into too much detail because that's another like big area of like kind of paradigm in there. It's really like it's handled by the thread. The thread will actually drive. It's essentially, think of it, functional programming is any function, like math function, right? You pass in something to do a job and it goes in and do it and then kind of processing and comes back like that is functional aspect. It's basically the control flow of the program is basically driven by a thread of execution. Now, so when I get to reactive, okay. Now, reactive systems. Okay, so reactive systems is more like on another level. It brings into another like abstract level. What it does is it actually would have to have message-driven capability, and it's inherently directed with like long-lived addressable components too. So now, if I go back to reactive programming, it's the programming part, but it doesn't care. It doesn't deal itself with, well, where do I find who's going to respond to my events? It's more like it's basically how many, I think in JavaScript, right, some of you have done this observable, right? Like if any observables that comes, it's like an event that happened is really an observable. So then you need actually someone to be observing it, yeah, to kind of respond to what to do with some events that happen. But whereas in a reactive system, though, it actually has an addressable component too. But your framework will handle. Like you don't actually have to worry on a programming level. It's like a true kind of reactive systems is that you do things and basically your framework, say an Akka system, it will handle the address of how do you send messages between the different components. So that's one thing. And also it focuses too on the resiliency and elastic. It's think of it more like an ecosystem managing things. Okay. So again, I just over here too, I also want to point out about event-driven and then message-driven too. So event-driven, think of it's more like events are emitted locally. And they also like it's ephemeral, like data flow chain there. Whereas in message-driven, it's basically the basis for communication in distributed systems. And it can be utilized for bridging like an event-driven system across the network. So event-driven, think of it, it's more like it's not tied to any, it doesn't have any idea of where things are. But the message-driven systems will actually help it to find things here in the system. And then also too, message-driven systems too will embrace kind of the reality constraints of distributed systems, right? It deals with like partial failure, failure detection, and some eventual consistency, which I'll go in a little bit later to talking about those. Basically dealing with concurrency within the system. Things are happening and the system or the framework will handle things. So like this diagram over here too, like I've just, I actually got it from Lightband to have this thing. So essentially too, event-driven, again, it's like you have things that are happening. It's like a soapbox. I'm like broadcast or not broadcasting. It's like events that comes. And basically you have a bunch of observer that will kind of like, I'm subscribed to this message, then I'll respond to it when the message happens. They won't do anything if nothing happens. It only responds to an event that happens. Whereas in like message-driven, think of it, I just use it like a stack of endpoints, right? So if there's something happens, it knows how to find things. It's like the all addressable components. So that's in a nutshell. Okay, so let me also like bring up again reactive programming, the patterns and terminologies. So reactivity is really the process of responding to external stimuli and propagating events. So that's reactivity. And the events themselves are stimuli that actually means that it stimulates, so then the observer needs to do something about it. And the streams are really like primitive representation of a sequence of data elements. And then I brought up to observable, they are really stream of events. And then design patterns too. I won't go into detail, like observer patterns, like it's kind of a little off, but it's actually observer pattern and composite and iterative pattern. Again, those I won't go into detail. I'm sure you are aware of those. Okay, so I'll just show a little bit then. If you go to, kind of hard, is it hard to see? No, is it good, right? You can see, right? Because over here, I think the color of mine. Okay, so I'm just taking this from the Rx reactive extension. How many of you actually have worked with like Rx, right? Reactive extensions, so you know. So they have these marble diagrams to guide you how to like learn about reactive programming. So as you know, actually to think of reactive, it's like dealing with timeline. Again, reactive, again, is like not a usual way of programming paradigm. So I'm just using this, think of the reactive as dealing with the timeline. And you have different events that happen. Something happens and over here too. Up top is just a timeline without any event, so nothing happens. But if something happens, it kind of travels on this stream, the stream of events. And over here, I'm using this kind of stop sign, meaning that you're propagating events and it's done. So it's something the stream will terminate. But you can also have events that are happening. That is first-class citizen. Meaning that the stream probably have to do something. Somebody has to do something about it. And over here is a stream that's continuous. Then you keep having like that travel across. And over here, let me give an example too of a map function. So again, I'm using RxJava. So using an observable event, they have a method called just, right? Just is basically, essentially, they are events that happen. Some data that travels on the timeline. So for example, over here, I'm using this is 1, 2, 3, and we're calling a very popular function in RxJava is with map. Map essentially is think of it as a transformer. It basically takes in whatever in your input stream, and then basically then over here in your map, you're like trying to tell it, right? You're telling it that what to do. So over here, this example is basically take whatever comes in, that's the x, the variable, basically transform it, multiply all the values by 10. So then you see that in the next timeline over here, that 1 will become 10, 2 will become 20, and 3 is 30 in this case. So over here too, in order to print it too, think of, actually in some ways you think of it, it's like the client and the server all in one statement, essentially. You map it, you're transforming it, like you service the function. And then you have essentially think of it not quite like client, but in some ways it's a client. It's all in one statement, right? So you subscribe to it, and what it does in here is basically like print out the result. The result is item 10, 20, and 30 here. So I hope it gives you some idea. From on a programming level, that's what, yeah, like kind of very basic kind of introduction. And if you're interested, you can go to to rxmarbles.com, and then they have also some like interactive too on the timeline. You can kind of test things out too and see what happens. And then there are now over here too, like in reactive terminology, the function is actually called an operator. So operator in reactive terminology. So the operator will basically operate on your stream. So there are different kinds of operator, like map is transformer, then there's filter. I'm sure you know, and then there are other ones too. So if you look up, you can kind of get more understanding of that too. Okay, now let me bring you to another thing is about the reactive systems design. I won't go into a lot of details because as such, think of reactive systems is a bit more like another level of reactive kind of computing. So there's also a book too, it's actually published by, I don't know if it's Lightband or maybe related to Lightband too. They go into very deep kind of principles, right? So they have these kind of, I kind of largely kind of lay out in here. There are different kind of patterns. Like if you want to go to bed, read that because it goes very deep, right? I'm not saying it's boring, but it's just, some kind of serious read. You get into details of really like about reactive systems. Because think of it, right? Human beings, we do things kind of, without thinking something is happening, but they try to capture that kind of kind of mechanism of behavior in human beings systems, it actually gets quite complicated. So those are the patterns. And then over here too, I wanted to kind of point out too, for example, like a pattern is called circuit breakers. How many of you have worked with circuit breakers? Right? So essentially, it's just like in physics, you learn about circuit breakers. So if there's failure going through the systems, then you have some kind of mechanism to break it, but then the failure doesn't. That kind of pattern in reactive. And then back pressure. Back pressure essentially is that if you think of the stream, you have data that keeps coming in. You need someone to process it, but the processing part is not able to get caught up. So in that case too, that's what the back pressure means, is that you're not able to get caught up to process it. So in a truly good reactive systems, is that it will say, okay, I'm the one kind of experiencing, I'm the one that feeding all the data in. Then I realize the system is backed up. Then my component will have the capability of telling my supervisor in the system. Now Akka has this thing called supervisor capability. You tell your supervisor, hey, I can't process anymore. I'm choking. Do something about it. So then your system then should have some ways of adjusting itself and deal with this kind of back pressure. So in a truly reactive systems, it should have this kind of capability. I believe a reactive RxJava 2 actually, or Rx2, they have back pressure support too. And then of course too, there's also high availability and eventual consistency. I brought up a little bit, but eventual consistency is conceptually, right? In a nutshell, it means that your data, when you send requests and you want data to come back, you want it to be correct, accurate, and consistent. However, in a responsive kind of reactive systems, you also want your data to be highly available, meaning you don't want to wait till you want it to come back in on time. So there's this one kind of a racing kind of condition, right? So it's kind of you want data faster, but it may not guarantee your accuracy. So what it does is that what it is that the eventual consistency is that sometimes, like if you're processing your data, your systems still return your data back, even though it may have some inconsistency in there. It believes in like eventually the system can adjust itself and the data will. And so then you can kind of meet the high availability. So those are kind of aspect of this computing addressed by, say, with Akka system. Okay, so one quick note too about what about like microservices, right? How does it get related to reactive programming and reactive systems? So reactive programming will basically, it's in a microservice is used within a single microservice. Your microservice do a particular task. So it implements some service internal logic and also manage the data flow. That's what essentially reactive programming is. But in a reactive systems, then basically that it will be used in between the microservices, and they bridge the communications between the underlying message-driven capability. And so it embraces and supports the responsiveness and resiliency and scalability and elasticity of a reactive system. That's a nutshell. Okay, so now we get into a little bit of a more like interesting things. I know it's kind of boring. Sorry, but that's just a kind of different way of thinking. So here too, I thought I'd throw in this slide because I saw this. It says slow down, spend more time observing. But observable is like the keyword in reactive asynchronous programming. So I just find it kind of interesting to say slow down and spend time observing. But actually in the reactive systems, you want things to respond faster. You have not slow down. But I just thought that was kind of interesting. So here, as we get into a bit more interesting things rather than the boring kind of concept. So I actually was in Tokyo recently in December for a Java user conference. And so in Tokyo too, maybe some of you have been there or familiar, they have ramen shop, right? So I went inside and then I realized, oh, there's no server. There's nobody taking your order. So over here, I just merge these pictures. So what they have is basically they have a machine where your vending machine, you kind of plug in and what do you want and all that, and then put in your money. And it's interesting too, there's no credit card, it's all cash. And not just with one shop. I realize many little shops, they just have cash. And then again too, on the ordering system too is all in Japanese. So it's kind of hard to tell. I mean, I don't read Japanese, but I read Chinese, so the kanji I can kind of make out. But anyway, I'm bringing this example in because I want to actually write a sample case using the reactive approach. So that's why I thought I'd show this. And so basically you order, you put the money in, then you get some tickets and then describe what you order. So in my case, too, I had like a bowl of noodles and some vegetables. So I got the ticket, and basically the guys, there are a bunch of 4 or 5 guys in the kitchen counter there. And then what you do is that then you wait in line because it's a very small place, right? There's no like regular tables like the normal restaurants that we have in here. So you kind of sit around kind of like a bar area. It's only like a small, very popular noodle shop, very kind of attracting a lot of people. Long lines, like 10 or 12 people in line when I got in. So in the meantime, too, I had to stand in line because they cannot serve it yet because there's no seats around the bar area, the eating area. So why it prompted me, why I bring this in, because then I'm thinking, gee, it might be a good kind of use case to make use of this reactive principle. Like, how can I do it, right? So I was kind of giving some thought. So I just thought I draw it out, show it to you. So here, like your customers come in, place an order. Think of the machine that I'm placing an order. And here I am thinking that my next thing try to do is maybe do a mobile interface. So basically I can just, actually I don't even need to go in. But let's say if I do go in here, it's got to have some web interface inside the store and basically take your order. So I place the order in there. So the order comes as an event, right? Think of the timeline. It's an event that comes in. I place an order, it's an event, it's an observable timeline. So I place the order. In the meantime, the waiters, the servers, right, behind, they are the ones that are observing to do something. Because order comes in, I need to start to do something. However, in that particular case in the ramen shop is that they can't really do anything yet because it doesn't have speed yet. So here it is. Also should have another observable in there, the seating system. So then if something opens up, then it's shown another, hey, there's an open seat, and that kind of work. So then the observers on this side for the waiter should then respond. Once I have an order, then I wait for an open seat to be available. If the two are good, then I assign the seat and go and my order over to cook the ramen to the cook, right? So then, yeah. So then over here, when you're cooking, then when it's ready, then you also have another observer. Have another event that says it's ready. But in that case too, then maybe there's got to be some kind of. Now, if you look back in here, my customer, after placing the order, becomes an observer because they're waiting. So they're eagerly waiting, and I should have some kind of notification mechanism to tell them that your noodles are ready, basically. So that's something I'm kind of thinking of. Maybe like like in a few months or something, I probably would do another talk on that, just implement and show it, and also kind of doing a mobile. I think it would be kind of useful, and in reality, mobile ordering system would be useful because I can be like doing something else. Like if you think in a real life situation, you can be doing something else. You want a noodle, there's an hour's wait. So then you place your order on your mobile phone, and it tells you when it's ready or roughly. Then when it comes and oh, no, it's not. Yes, then in that case.
How do you iterate like a or they just carry that state memory?
Yeah, so that's a very good question too. So right now, some of the systems too, for example, they are mostly like in memory systems that I know of. Actually, you bring up a good point because right now too, there isn't any like true database support of reactive systems, if you're aware, because the I/O, let's say, right, okay, there are connectors, for example, RxJava 2, like some connector, and also Vert and Spring is called out to something, yeah, and then Oracle also have an 8 something, I think I read that. So over there too, they have like connectors that are non-blocking connectors. However, the database engine, let's say relational database, I don't think, and that's what I would be trying to look for, like doing research too. I'm still doing research to see if the database engines themselves are doing non-blocking I/O on the database lower level. But I don't think they truly are having that yet. But going back to your question, is that that's a very good question. I think in that case, then basically, if it's on Akka, then there should be like mechanism in which I can utilize to kind of manage this kind of, essentially it's the state, right? Your data that it manages, like it holds on to it. If all of a sudden it crash, it still needs to be able to recover, that type of stuff. So yeah, but that's a very good question. Yeah. I think okay, so I'll go a little bit too. Okay, thanks.
Yeah. Does hold it as the operator, basically wait to observe by the operator. Both of these have completed forward and the operator. So
Okay.
it doesn't hold create your own operator, so I'm sure that
yeah, that's right. Yeah, that's true. Yeah. Now Akka has capabilities of kind of that's what it is, a true reactive system that can kind of manages the kind of state for you. Then yeah, it takes care of failure situation. Yeah, thank you. Good question. Yeah. Okay, so I think that because looks like I have like 5 minutes or something, so I didn't even know how you kept talking. So I just want to quickly go over maybe the last 5 minutes too, because as such, I represent like Java side, so then want to talk a little bit, bring up so that you are aware of it if you're interested. So reactive extension, RxJava, already some of you have worked with it or in flavors of reactive extension. So for Java, we have RxJava, and that's really the Java port of the reactive extension. Actually, the reactive extension, they started off in .NET. They are really a Microsoft invention, reactive extension. And but for Java, Netflix actually came in and did a port of it to Java. And it's quite recent too. It's only 2014. That was version 1, and now it's like version 2, 2016. And basically have the flowable, the back pressure support. Okay, so actually reactive extension also has ports to not just Java. It has it in Scala, Clojure, Swift, and a lot of language flavors too. And a very simple example of why I also feel too reactive systems should become more prevalent, or and it's not for every single situation too, but I do believe in that having such an elegant programming construct, I think it should become more mainstream too. Eventually, when folks kind of becoming more comfortable with using such a paradigm. So over here, it's just a simple hello world. So basically, again in RxJava term. So you basically only one statement, you take care of the whole thing in a hello world, right? So in normal, say Java too, you kind of say, okay, I take my argument and figure out what the argument is, and I have separate statement that take it and then interpret it and then print it out. But here you can actually do it in one command, basically global, and you do the chain it together from array, take the arguments and then subscribe. Again, subscribe is like the client that takes your argument and do some basis system out print, system out. Say hello to somebody. And also just another like quick example. Sorry, somehow it's kind of off. In any event, I think you can tell too. This RxJava 2 example. So for observable, I think I also showed the map operator already doing just, so that becomes like the events. It's like this when you stream those events, and your consumer will. Your consumer in here is doing a system output. And then the observable will subscribe. Basically, that's how you attach the producer of your events to the consumer doing a subscribe. And I believe in JavaScript it's the same. Here I'll go into like Spring Reactor too. So Spring, how many of you have worked with Spring framework? Yeah, you have to. So Spring Reactor is basically based on Project Reactor and similar to RxJava 2, essentially, and built for Java 8 for cleaner interface. So basically, too, over here, the project lead for RxJava, David Carnell, and engine contributor to Reactor. Actually, I found this too in Twitter. In 2016, he said use Reactor 3 if you're allowed to use Java 8 and like newer Java, but use RxJava 2 if you're stuck on Java 6 or version of Java. So, and again, I just list out a list of all these Reactor libraries. The core one is what you want to use. All these other ones. It also has like incubating reactive stream foundation for like .NET and JavaScript as well. It also has integration with Kafka and Rabbit. hurry up a little bit. Okay, so here, another code example of Spring Web Reactive. So it's basically a non-blocking for Spring as this non-blocking website. So over here, quickly, I'll go through. The first example over here is the traditional approach using Spring MVC. So over here too, to get all products, like you see that the first line is trying to do system out print line. And so in a traditional sense, it's a blocking call. Over here, what it does is it will wait for you send that call, right? Get products is the blocking call. So then it will wait for all the products to come back, your result to come back. Then when it's all come back and returned to the list of products, this line, the next line, system out print line, traditional way completed will then get printed. It's essentially it's waiting. But in a reactive approach, like Spring Web Reactive and Web Flux, and then if you see in here too, is that we'll print out the first line, and Flux too is the one in Spring that takes care of the asynchronous mechanism. So basically, if you print out the first line, it's reactive way using Flux started, and so the next line that comes, it goes and calls and products, it returns Flux. Essentially, it's the Spring Flux. So what it does is, it's not really going to return your list of products. What it does is telling you, okay, I'm returning Flux products. Think of it like a handle. So then it goes off. The Flux will again go off. And it does is gather all the products. Then you'll find that you actually will get out of using Flux because what happened is that this thing is still being like processed. So, but over here too, then basically too, it also won't wait. Even though it's returned the Flux products, it's just a handle into that. So then when it's ready, then you can try and go and kind of figure out what to do. So that's what it reacted actually. Okay, so I'll go in here quickly. Just a quick comparison. RxJava and Reactor, the differences. They're about release. The latest version are for like 2018, released at about the same time. So yeah, and I can have these made available too, instead of me. They're just similar essentially. So just quickly too, I just want to again talk a little bit about Akka. Akka is IBM partnership with Lightband. Akka model, it's actually already came. It's not a brand new thing. It's basically from 1980 from Erlang programming model. It's basically Akka borrowed from that concept. And it's event-driven, location transparency, lightweight. And again, I point out about the supervisor capability. It's really pretty powerful in terms of taking care of failure scenario. And this is just a quick example too, but this is actually in Scala. They also support Java. I'll give the slides. And then just the last tool I want to mention about is Vert.x, and that comes from Eclipse. It's a relatively newer framework too, and it's really flexible, polyglot framework. So basically, they're just libraries, and it interoperates with other frameworks too. So you can mix like your Vert.x with RxJava and Spring Reactor, or Akka, or other frameworks, and they don't make use of an actor model, but it's called vertical. That's what it is. So basically, the components that are being deployed and executed by Vert.x, they are event-driven, and they run only when they receive a message. It has its own event bus as well, and it's pretty flexible library. And over here too, also like a quick example of Vert.x over here. Again, it's the reactive programming style. Basically, too, is called Vert.x, and basically you create like a HTTP listener, and basically you can chain your commands together, and basically to your request comes in, and it is listening on port 8080, and then you pass in your hello world, and it will get printed out. So your response will then return hello world. Again, you can see like reactive programming style is a lot more like concise and shorter. Because otherwise, if you do things in the old-fashioned way, you're gonna get some products, you're gonna look through and transform and all that. But you can actually in reactive style do a map, some kind of map function. You can do it in one single command. Okay. Okay. So now I just have a quick recap and takeaways. And reactive is an overloaded word. And it's not for the faint of heart, but it's for the determined. You can always learn it. It's just give it some time. You first pick it. If you haven't learned it too, and you want to start learning about it, just keep working on it. It's just it will take some time. It's a declarative style of programming. It doesn't go into all details like imperative programming that our minds. So again, it's not the same as functional reactive programming or reactive systems. And some of the benefits I already discussed of reactive on the programming level. And then reactive systems and architecture, for example, like Akka, they really bring reactivity to another level. And then, then I talk about a bit about database. So far to this day too, there has been like database driver that are developed like non-blocking. But again, like say for example, right, there's Lightband has this thing called Slick, and it's Slick is like a community-driven or community-developed database connectivity connector, but that's only in Scala right now. But if you're interested too, you can take a look at it. Otherwise, too, RxJava 2 JDBC is also like a reactive non-blocking connector, and Spring also has R2 DBC. And also, I believe they also coming out with for NoSQL support is for Mongo. Spring has like a driver coming out. It's more like kind of beta version at this point. And then I believe Oracle to also come up with ADBC too, that also has like a support of non-blocking database connector. But as far as the database engine goes, again, I don't think they truly have any non-blocking I/O support underneath, like in the deep down like database I/O level. So yeah, again, to make a system really reactive, you do need everything like operating in reactive manner. That's what it is. Okay, so I think that's all I have, and thank you very much for coming. I will make the slides available to you, and then you can look up some of the information here. But I also want to quickly point out to you, like for IBM, I work for IBM, and we have an initiative called Call for Code. It's really for like disaster preparedness, the hackathon. We just had one in 2018, but in 2019, there will be announcements made about it. So I encourage you to look that up and also maybe sign up for the hackathon. And it has prize money associated with it and for a good cost. So I'd like to invite you all to kind of watch out for that. Okay, so that's all I have. Thank you very much. I appreciate it. Thank you.